So good morning, good afternoon, good evening, everybody. Thank you for joining us today. I used all those time zones because we literally have people from all over the world on this one, including the panelists who we'll introduce in a second. My name is Ian Gillett from IGR, and today's roundtable is brought to you by Supermicro, also with the support of Intel. And we'll talk a little bit more about what we've done here in a few seconds. But just before we get started, some housekeeping to go through. Firstly, this is being recorded, so it is live, but we're also recording it as well for an archive. And after the session, we will send out an email with details on how to download the recording or access the recording. For any colleagues who aren't able to make it. So feel free, you'll get an email for that, but feel free to send that around to anybody you think could be interested. We are streaming this as well through the computer, so volume you can adjust through the computer as well. And we will be taking questions today. Rather than doing the usual, a lot of webinars, they do 10 minutes of one speaker and 10 minutes of another. We're actually going to have a discussion today. We've got three main questions. We're going to let all the speakers discuss that question, and then we'll move on to the next. So I will pause and take questions from the audience as well. We did quite a few questions when you registered. I have all those, and we'll work those into the discussion today as well. But if you do have questions as we go along, on the GoToWebinar control panel there on your screen, there's a questions tab about halfway down, and you can just type in any question there, and we'll work them in as we go through. Okay, we'll also have time at the end for any questions that are outstanding. The final thing is we do have a white paper that we've been finalizing. Actually, we're nearly ready with it, and that will be published shortly. Again, you will get an email about that with how to download and access it, but basically on the same subject, obviously a lot more detail and some more pictures. But basically, so that will be coming out quite shortly here, hopefully next few days. We'll say we're nearly finished with it. Okay, so with that, let me, so in terms of the agenda today, I'm going to introduce the panelists in a minute. I'm then going to give a very quick overview of private networks in terms of what they are. We'll talk about typical hardware, and I do actually have something to show you as well. And then we're going to get into the three questions and really the meat of the discussion with the panelists. What are the best practices for deploying a private network in the enterprise? How do you future-proof that private network? Obviously, as the enterprise needs change, nothing is static. It's a very dynamic environment. And we would expect that these networks are going to be out there for multiple years, if not decades. And then how will the hardware and software change during the life cycle of that private network? So as the private network evolves over time, how do you scale the hardware? How do you scale the software? We're going to talk about some analytics and those things. And again, just submit your questions on the GoToWebinar control panel there, and we'll work them in, okay? So with that, I'm very quickly going to just introduce the panelists. Yaming Wang from Supermicro is actually in Madrid today. Yasser Khan, who is from Micro AI, is in Melbourne, Australia. I'm in Austin, Texas, by the way. Michael from Supermicro, Michael Clegg, is, where is he? He's in San Jose, California. And Venkata Mova from HTC is up there in Kansas City. So I think we've got we've got three continents there. The attendees today, I've looked through the list, and a lot of European, a lot of Asia as well. So a very diverse group. So firstly, the first thing I'm going to do is I'm going to come back to the speakers in a few minutes and just ask them to introduce themselves and what they do. But what I want to do first is just talk about what is a private network. And this is a diagram we've used. It's kind of a generic metro market. You can see we've got 5G macro cells on either end of the picture here, providing 5G coverage. The small cells, the yellow areas, are covering a home or a stadium, manufacturing plant there you can see. So a small cell deployment. But the green circles you see really depicting a private network. So it could be within an airport, for example. Love Field in Dallas has a CBRS network running. It could be in a Class A commercial space or other commercial offices, and there's plenty of examples of that. It could be in a manufacturing plant, a warehouse, storage, some sort of distribution facility. And logistics actually is one of the big use cases for private networks. And then the other one, of course, is the stadium. Football season here in the US has kicked off. But obviously you've got 100,000 fans in a stadium, capacity is needed. CBRS networks, private networks in the US using the CBRS band have been deployed, for example, in some of the big football stadiums, so that the concessions and the vendors can actually swipe credit cards. The Wi-Fi is congested with people trying to send video and images of the game, etc., etc. So they actually put the credit card swipes, the security cameras, some of the other more or less critical communications onto a private network. So they've got sufficient capacity and obviously response. And then healthcare is a popular one as well. Obviously hospitals have always used in-building networks for communications. We're now hearing of hospitals being built where they've got Wi-Fi, but they've also got private networks built into the fabric of the building from day one. So lots of different applications. We could go on for hours just on the applications here, but really we at IGR published a series of reports this year or this summer. We have 12 different vertical markets, from education to healthcare, transportation, logistics, entertainment, etc. It is as wide as the enterprise market is broad. Okay, and then if I just the hardware that's commonly used, and I'm actually going to show you something here. This, if you can see it, this is actually a Supermicro server. This is actually running the EPC packet core I have for a CBRS network in my office. I just unplugged it for this, and you can see how small it is. This is obviously the size of my hand. And this is, if you look inside, you can see actually the Intel chips in there. So this is powered by Intel, but the entire packet core runs on this. And obviously this is a small deployment. I've got one radio on the back. You can see you can plug in a couple of radios on there, but it's actually running the Ethernet EPC software. But Supermicro offers a range of scalable products here to support the greenfield private network, obviously expansion and growth as it scales over time. Obviously Supermicro's products here, featuring the Intel technology, you can deploy in multiple locations. It could be on the customer premise, it could be the edge data center, central office, etc., etc. Obviously the one I've got here is the standalone for a small office. But we'll talk about this as we get into is this building block approach, the product portfolio, to allow the solutions to scale over time. And you can see there's a couple of the hardware solutions there on the left-hand side. Okay. So this is what we'll talk about today, is how we scale and how we bring all this together. So I'm going to go back to this slide, and what we'll do first, very quickly, just take a couple of minutes for each speaker, and I'll start with Yaming first. So Yaming, who are you? What do you do? And I'll say what does Supermicro do in this, but of course we've kind of introduced that a little bit anyway. So Yaming?
Yeah. Hi, Ian. Thanks for the introduction. My name is Yaming Wang. I'm actually based out of San Jose, California, but today traveling in Madrid, Spain. So I have the pleasure to talk to you from a hotel room. Hopefully the connection will be good. I'm part of the engineering team here at Supermicro, responsible for the 5G Edge solutions. I've been working in the telco industry for over 20 years, from a total solution, working with operators and also working as a software provider in this space, and also IoT as well. So I've been working with enterprises as well on the private network. Would be glad to share my views on this topic.
Okay, great, thank you. Yasser, I know you're connected in from Melbourne. So who are you? What do you do? And what does Micro AI do?
Sure. So my name is Yasser Khan. I'm based out of Dallas, Texas. Today I'm traveling to Melbourne, Australia, and I'm also using the hotel network. So apologies if there is any disruption. A little background about Micro AI. We are focused on understanding machine behavior using artificial intelligence and machine learning. So our applications are in specifically in industrial environments, and also environments which are rich in infrastructure. And usually use cases require good network, sometimes private network with low latency. So this is a very useful topic from our perspective. Yeah.
Okay. And I was looking at your website yesterday. You do cover a variety of different vertical markets, including telecom, but I think some of the others were healthcare and some of the other. So you do have experience across different verticals, yes?
Yeah, absolutely. So we do a lot of deployments in the telco space as well. And as you can imagine, the smart connected machine ecosystem is ever pervasive across many different verticals. So we're working in oil and gas, we're working in smart buildings and healthcare implementations as well. So
yeah. Okay, great. Michael from Supermicro, who are you? What do you do?
Hi, Ian, and hi, everybody on the panel. So my background, again, has been predominantly in telecom, really on access networks, both on the infrastructure and customer side. And for me, what's exciting about private 5G is it's actually a next generation access network aimed at the enterprise, where you start to merge some of the traditional telecom infrastructure with what might have been typically be deployed in an enterprise. In Supermicro, I work very closely with counterpart Yaming here. My focus and my team's focus is really a little more go-to-market, predominantly around partner relationship development, so we can bring together complete solutions as we engage with the market. And you see some of our partners over here, and thank you for participating today.
Great, thank you. Venkata, HTC, who are you, what do you do, and what's HTC's involvement within this private network environment?
Thank you, Ian. Hey, hello everyone, and I just wanted to say thank you for taking the time to actually join this morning. I've been with HTC now for 15 years now. I've launched all of the phones that ranging from a 3G to the 4G to the 5G phones. And what we have been doing for the past 3-4 years now, which has been our bread and butter now, is virtual reality. What we have announced actually this year is a private 5G network with our virtual reality, which provides a complete end-to-end solution. And I'll be talking a little bit about that, where we can actually reduce the latency of the end-to-end transmission down under 15 milliseconds to provide the best experience. After launching a decade of phones, I'll say that if you ask me, do you need 5G on your phones? Probably not. But if you need, do you need a 5G, a private 5G or something like that on your with your virtual reality headsets, training, design, and everything? Yes, absolutely. I'll pass it over to you.
Okay, and to tell everyone, I have seen the HTC demo actually with regard to the virtual reality, and it's not just for gaming for teenagers playing Fortnite or something. There's a lot of industrial applications for augmented reality and virtual reality. Certainly things like putting in data centers and the right connections, but industrial applications where you're looking at assembly or repair of a complicated piece of machinery, for example. So everybody, when you say AR, VR, everybody thinks gaming for some reason. So
yeah, thank you.
Okay, thank you. All right, so let's go to the first question here, and I'm actually going to start off with Yaming first for this one. So what have we seen here? What are the best practices for deploying a private network in the enterprise? And clearly, we're at the beginning of this growth phase for the industry. We've seen private networks for the last couple of years around the world in different verticals. But from what we've seen so far, what would you say the best practices that you've seen out there, Yaming?
Yeah, so I want to start with, you know, in my view, right, there are several ways to deploy a private 5G network. Largely, you can differentiate between a operator managed network or a standalone network. For the operator managed network, the operator will own the overall infrastructure. Typically, the core network will be shared using the operator's existing infrastructure, while additional RAN or radio access network is deployed to the enterprise premise. For the standalone, the enterprise themselves will want to own the network. So the core and the RAN are all co-located on-premise in the enterprise network. The reason why an enterprise would choose to build their own or versus go with operator, there are a few reasons. Number one is the spectrum availability, whether this country has available spectrum for the enterprise to be able to use private network at a low cost, right? And also typically smaller companies don't want to spend capitals to build their own. They'd rather leave it for an operator to manage it. And for the data privacy concerns, some large companies, their data is so valuable to them, they don't want to go outside of their campus. So they want to manage their own network rather than let the data go to operator's core network. Then there are actual deployment scenarios, such how powerful the radio should be. If it is all relatively a kind of small indoor environment, then a all-in-one kind of unit, like the example you showed Ian, right? With a small radio might be enough for a small office environment, but there are some cases a large enterprise has a big campus. It will need to cover both indoors and outdoors, and they require pretty powerful radios and probably several cell towers as well. So they're all kind of different cases in my view, right? Depends on the particular customer. So I will just leave to other panelists to chime in on, you know, from different angles on how they view this topic as well.
Okay, so Yaming, I'm going to put one little follow-up. I'm going to put you on the spot here. So the other panelists are going to get advance warning. But what would you say is one of the most interesting verticals you've seen using a private network? What jumped out to you? It's like, wow, that's really neat what they've done.
Yeah, one of the example is I have seen a large manufacturer based in Asia, so that they actually need to build 7 cell towers to cover their campus. It's a pretty large compound. They have R&D labs, manufacturing floor, and office buildings. So they actually are using a lot of video as applications, where they have the mobile phones handset for the employees that can use this private network to be able to do like tracking the productivity, and also use the mobile phone for video inspections of their product lines as well. And in addition, they can use their mobile phone for other communication purpose as well. So in their central location, there are kind of GPU type of server running there for AI inferencing, accelerate that purpose because they do have cameras all over the campus for quality control to reduce some manual labor as well. So it's a pretty interesting use case. I think also it's typical as well for inspection, quality inspection, and also for communication, and some of AR, VR capabilities being added in the future. So I think manufacturing is a very important vertical for the private network.
Okay, good. So, Michael, what best practices have you seen from your perspective from the enterprise?
Yeah, so what I'd like to bring an additional aspect to what Yaming has already said. First of all, as you mentioned earlier on, the amount of verticals that you could use a private network in is, I don't think there's a business or an application that could not take advantage of a private network. I'm of the view is that private mobile networks are complementary to Wi-Fi. So it's not an either or, it's not an industry debate about does one change the other. Ultimately, like any business decision, it's about what works best. And so when is mobile best? And typically the word is right there, mobile, right? When you need a degree of mobility in your network, with Wi-Fi, your handover is not as good as you are on a mobile network, which is fundamentally built for that. You're going to get the benefits. And of course, you've got a little bit more of spectrum control, even on the unlicensed private 5G. It's the way the spectrum is managed. So that's going to give you a bit more security. Probably the other biggest advantage of private 5G is range. So the first thing is, look at your need in your application. What is the best technique you want to deploy? It is still about RF coverage. The other thing I would say is a lot of the private networks, it's not private mobile networks for private mobile network's sake, is you want to have an application. And one of the applications is really around digital transformation. So as people look to what do they do different in their system, that itself will then drive the need for connectivity, and that will then drive the need for what is the best connectivity solution I get. And it's going to vary a lot. Do you have a small cell-based network, as Yaming said, depending on your application indoors? But if you're in a large campus environment, you want more of a macro radio network approach. So architecting the network that's optimal for your configuration. So there isn't, one size fits all in private 5G. It's going to be like any network design. You're going to have to design your network for your application. But the other thing that I'd like to bring out is there's two aspects. There's the network side, but typically the reason why you're doing private 5G is because you're trying to run an application. So you have your application side as well. And in the servers we showed earlier, they often have dual processors or multi-nodes. The example that you had on your slide was multi-node, where you would have one node maybe running the EPC and the core for the mobile network and the other node running the applications processor. So as you look at your network, remember to scale your application side to be commensurate with the application that you're looking to deploy.
Okay, and you can't say manufacturing on this one, but what's one of your favorite applications or verticals you've seen for a private network?
Yeah, one of my favorites, and I'd have to say this is a little bit hearsay, it's not one we've been directly involved in, but really stood out for me, is it's an inland port application, so a large container port. And the reason why that came up is it started as a digital transformation exercise. It's amazing these trucks are still very paper driven, and they were trying to automate that. But the challenge with containers is as they stack them in the field, they're perfect RF shields, and trying to get a decent signal down each of the containers and onto the containers. Then of course a port is huge and you've got mobility. So it turns out this is a great application for mobile private networks. It's a large coverage area, so the expanded radio reach of a private mobile network is good. There's a mobility application involved, so that's great as well. And you've also got a lot of security that goes on the SIM cards and the benefits that private 5G brings. So actually, I think logistics, transportation, warehousing is a great application for mobile private networks.
Yeah, I actually toured one of the big ports in Asia a few years ago, and I was surprised. They told me how many containers they lose in a port. They know they're there. They just don't know where they are, and they got stacked. They got stacked in the wrong place, or they're in the wrong part of the port. And they have to. There's a whole team that spends their day just going around moving containers to where they're supposed to be. But you're right. When they're stacked 4 and 5 deep, they make great RF blockers. They're really good. So good. Okay, Yasser, same question here. Obviously, you come more from the analytics and machine learning side of things here. So the private networks you've seen, you've been involved with, what best practices have you seen from the data analytics side?
Yep. So as we are involved with the digitization, sensorization of OT infrastructure, operation technology infrastructure, there's a lot of data which is generated from the environment at a very high speed with a very low latency requirement. And a lot of times these infrastructures, this industrial infrastructure has a network which is a legacy network, can really handle this type of a traffic. So a private network is a very good application deployment infrastructure for some of these use cases where we are collecting a lot of data in the local environment, doing analytics close to the source of the data. And as we saw with the architecture of some of those pieces of hardware, which are kind of scalable, now you can look at deploying applications which could be Kubernetes based, which can auto scale up and down as the requirements are created in the environment from the application perspective, and having a low latency network which connects the sensors which might be out in the infrastructure, whether we are talking about manufacturing environment or infrastructure like ports, where you might have information coming in form of like video streams or sensor data coming through. It's important to be able to capture that information quickly, analyze it, produce the result, and show that results in near real time in the environment where it's being generated. So
good. So again, same question for you. What's one of the most interesting, almost surprising applications you've seen with private network? Made you go, wow, that's cool.
Yeah, absolutely. Yeah. So oh, go ahead, Yasser. Was that for you?
Yeah. Yes. Sorry. Yes.
Okay. So the application which I've seen is the aspect of sensorization again of a manufacturing line in Asia, and specifically being able to isolate the data which is generated for use cases of predictive maintenance and operational excellence, being able to understand the productivity of what's happening in real time on a manufacturing floor, and at the same time isolating it from the IT infrastructure, so kind of creating almost a new layer of data visualization on top of an existing brownfield deployment where you might have like machines which are already deployed, which lack the capacity or capability of being able to take that information and be able to visualize it. So by putting a layer of sensors and connectivity which is private outside the existing infrastructure, and enabling use cases like real-time predictive analytics is pretty compelling.
Yeah. Good. Okay, Venkata, I know you've been waiting patiently. So best practices you've seen and best application.
Yeah, absolutely. So I think let me start off with, I mean, as you guys all know, private 5G is meant for not just for one purpose or other. You can do it for AR, VR, it can be for videos, it can be for so many different applications, the private 5G part of things. What I'll focus on is when you're deploying a private 5G network, think about the application, what kind of a content that you're going to be running, whether it is, I'm talking in context of an AR, VR training experience or a design experience. The next question that you'll ask is, how many people are going to be in that room together, whether they're designing or reviewing a design or whatever, or going through a training for that. So those are the two questions that I would ask before thinking of what kind of a private 5G network that I want to deploy, and the room size and everything, like Michael and Yaming were talking about before. That absolutely also matters. The best use cases or the best practice that I've seen is large auto manufacturers actually using AR, VR, mainly VR for design purposes, where they have a high fidelity content, whether you're looking at a design of a car, and this is running at 120 frames per second, this is at a 5K resolution. Any kind of a lag or jitter would mean that you would see artifacts in this kind of an environment. So you don't want to have that, right? Because once you have some sort of a jitter or a lag, you would probably not put a VR headset again, and that's it for your design design project that is going on. And that is a really interesting piece of thing that I've seen, where private 5G plays a huge role, because Wi-Fi networks are simply not able to meet that kind of a fidelity associated with design.
Okay, great. So we've had several questions come in, by the way, from the audience, but one that came up earlier as well, and I've seen it's been asked as well today. And Michael, I'm going to let you comment on this just very quickly. We talk about private 5G networks, we talk about private wireless networks. Does it have to be 5G, or can we have 4G LTE as a private network as well?
That's a good question. Well, in reality, probably 99% of private networks deployed today are 4G networks, mainly because the 5G network technology is still fairly new, as well as the spectrum. There is a hold up in the short term on endpoint devices that fully support 5G that is rapidly being resolved at the moment. So I think the combination of spectrum and additional devices will enable private 5G networks. The one difference I would say between 4G and 5G is that 4G private networks are a little bit of a bolt-on. The architecture was not designed to support it, whereas with private 5G in the 3GPP architecture, private networks are an inherent and fundamental part of the network. So going forward, it will be a little easier to have private 5G networks that work seamlessly with the core.
Right. Good, good. Okay, so next question. How do we future-proof the network against the enterprise's needs? Obviously, the enterprise is going to grow, it's going to change. They're going to have, new locations, new applications. They may expand a hospital or a storage facility or a port. But we've got durability, we've got reliability. We need obviously ROI over the life of the network, not just initially or eventually. So how do we future-proof these private networks once they've been deployed? And for this one, Yasser, I'm going to start with you. And obviously, you're looking at it from the data analytics point of view. So how do you look at the analytics over the life of the network here to ensure that durability, reliability, ROI?
Yeah. So the most important piece of deploying a private network is driven by the business case, right? And that's where the ROI comes in. And from our perspective, the AI ML analytics is defining the ROI of use cases these days. So it actually creates the opportunity to be able to implement use cases, especially from a perspective of industrial IoT. That's where our focus is. And in those cases, it's very important that you have a architecture of application deployment which is scalable and can change over a period of time, because as you grow the environment where you're deploying the solution, there is a need for it to be evolving. So think about it, that these private networks are giving opportunity, especially with low latency. It's giving opportunity to replace cloud and be able to do applications which are now in your local environment, where you have control over your data and you have control over the visibility of access without having a turnaround by sending all your data from your environment into a cloud infrastructure, running some cloud-based analytics, and then providing users insights into the application, from that perspective. So
good. Okay. Venkata, how do you see the same question here? How do you future-proof the needs as the network as the enterprise needs change over time?
Yeah, what we have seen actually, and this is something that we actually completely understand as going up or scaling down is one of the major advantages of actually having a private 5G solution with a cloud VR for training or for design. I'll talk about it from that perspective. For a training or a design perspective, if you are running the content actually on an edge cloud, and what that VR device or AR device will become is it becomes essentially like a streaming device, because the content is running somewhere else, and the content is just an instance of it running somewhere else. You are going to be obviously saving the saving your headset from not having high power processing being done on the headset. So you don't have to worry about the battery too, which is great because it's just running as a streaming device and nothing else. What that does is, if you have a company today which is going for let's say, for example, 10 users joining a design or a training experience, so to speak. Tomorrow they want to scale up to 20. It is pretty easy to go up where you are actually just taking 20 instances, 20 Kubernetes, as Yasser was talking about, instances content running on the edge cloud. And we announced our partnership with Lumen actually earlier this year, which will provide our private 5G network that cloud infrastructure that is needed to actually scale up or scale down. So that's the way I see it.
Okay. So I guess because you're running in an edge cloud as well, let's say there's a manufacturing facility and they open up a new plant in a different state, you could have the same applications running on that local edge cloud for that new facility and scale that. It doesn't have to be within the same facility, right? Is that correct?
Yes, that is right. What the edge cloud actually will do is it will dynamically look for whichever is the closest edge location that it can actually render that content for you, and
Yep.
it will use that content. So that way you don't have to. I mean, you can have essentially you can have people joining from the East Coast or the West Coast into a single design session or a training session and be able to experience this. But the private 5G is still going to be on the premises where your employees are going through that training or design experience.
Okay.
And if I can add to that, right? The private edge, offers capability where you can actually federate the learning across multiple locations because of the fact now that you have lower latency network in the specific locations and across connectivity across multiple locations. And that way you can actually share the analytics, which traditionally has been more difficult between different locations, without using expensive cloud infrastructure. So, and that's a very important piece, and that's our focus with Supermicro as well, with the hardware infrastructure and our application framework combining it. So, yeah.
Good, great. And just to let you know as well, Venkata, we've had a request for somebody is actually asking if they could have the see the architecture for that AR VR solution you've been talking about. So we'll do that after the fact, afterwards. So. Good. Okay, Yaming, same question here. How do you future-proof?
Yeah, since we are a hardware company, I want to talk about it from a hardware point of view. I will focus more on the large enterprises. For smaller companies, they're using those kind of all-in-one equipment. Yes, there is a potential to update the software for future functions, right? But since the hardware is kind of all fixed in terms of its own functionality, so very likely in the future the whole thing needs to be replaced to add additional applications. For the large enterprises, I think it's better to go with an open system rather than more of a closed one. I'm sure the audience is aware of Open RAN, which is using an open standard to build a disaggregated network. Right. When we separate the radio unit, for example, from the DU, CU, and the core network, customers will have the ability to choose the best in class rather than lock into a particular design. Open RAN also uses the commercial out-of-shelf servers that leverage the innovations from the faster-moving cloud and the data center world. This will ensure the deployed servers can have up-to-date technology to achieve the best performance and efficiency. For example, I'll go back to AI, right? Since this is such a hot topic, it's widely used by the enterprises to improve their productivity and create new applications everywhere. At the edge, inferencing is really key for that. Commercial servers built on latest hardware will be able to fully utilize the latest innovations from GPU vendors to accelerate the workload. Since this is a fast changing field, a disaggregated network with the latest hardware will ensure future-proof for best technology.
Okay, great. So Michael, over to you for the same question here, how to future-proof it. I'll leave it on this slide, so we've got a picture of the hardware there a little bit more. But how do you see the network evolving against the enterprise's needs?
I think we've heard some of the the buzzwords that are key to me in this. It's really all about the software. What you're basically building is an edge cloud. You want to adopt hyperscaler techniques. Yasser spoke about Kubernetes. So this entire system is going to be virtualized. So you're going to have abstraction between your software layer and your hardware layer. So those two can evolve independently. And this will allow you to bring different software applications or different vendors in over time on the upper end of the stack. At the same time, this is all running off commercial off-the-shelf hardware. So you're getting the benefits of the scale of the overall industry. It's not an appliance that is just focused on private 5G networks. And at the same time, this virtualization layer lets you introduce new hardware without having to go and change all your software. So to me, from day one, you basically build this as a virtualized microservices type application network, and that will allow you to grow your hardware and software independently over time.
Right. So the last question I have was really how that hardware and software changes, how it grows, which we kind of touched on here in the last question here. And Michael, actually, I'm going to let you go first on this, but let's expand this a little bit. So, I've showed my my server here, which is also probably the smallest one you could get, just for a single radio. How big can that scaling go with that virtualization and that edge cloud deployment for an enterprise? I mean, what's the upper limit that you've seen?
Well, there's really no upper limit. As you said, you can start on a very small network that can run on a single edge device, fanless device. If you have a larger network, we spoke about ports or factories. Yamin gave the example of multiple towers. You might run that on some of our rack mount servers, some of our multi-node servers, where you will aggregate the workloads across several servers, both on the network side as well as on the Mac side. That, of course, starts to bring redundancy in. If this is all running a Kubernetes containerized network and one server goes down, you can just move the workload onto a different server. Of course, in the industry, there are moves not to necessarily run everything at the edge. You have people like Amazon announcing, running private 5G on the hyperscale core with just an edge device doing a support node. So that gives you that type of scale. One area I think we will see in private 5G is multi-site. You mentioned that earlier on. So you build these edge clouds and then you connect them all over an SD-WAN, which itself is a software-defined network. So really, software is going to drive the network. And for us, it's all running on standard commercialized hardware. There's no bespoke appliances over here. So that's really going to get your life cycle to evolve. And one thing I would say that we do see just in edge applications in general, and this will certainly be true of private 5G, is a lot more video. Really, video and low latency is going together. And low latency is going to enable the AR and VR applications that Venkato was speaking about. So we will see the bandwidth demands go up significantly. And really, you will be required to have some kind of edge network to handle that bandwidth as well as the latency that comes with it.
Yeah, we've seen that. We look at the bandwidth demands of the network as a whole, all of the mobile industry, and we've seen it over the last several years. The bandwidth demand in mobile grows consistently around 40% a year, 35–40% a year. And it's video that does it. Move from standard definition to high definition, but look at a website today. No website is complete without a video clip, and you start looking at that on your phone or on a tablet device. Obviously, that uses more bandwidth, and obviously we'd see that in private networks as well. So, Venkato, from your perspective, you talked about the AR, VR. How many users here could you accommodate? You talked about the manufacturing, for example, and some of the auto design use case. Is there an upper limit to how many users we can have doing these low latency, high bandwidth applications?
Yeah, so the use cases that we have seen so far is like in a design thing, number of users that we can go is we can actually have 12 users in the same room. actually experiencing a design or a training experience is what we have done so far. Again, there is definitely, we can go push it up to 20. It depends again on the content, the application that is needed for this AR or VR device that is running on the private 5G network. What I'll say this for sure is that private 5G networks are the way, because what we are experiencing, especially even in the smaller, think of education sector, right? Even in education sector, what we are hearing is that if you have more than 3 people in the room, that's a cutoff point where they have to rely on some sort of a private 5G network. So that is not the case with most of the thing. As you go from education to healthcare, especially to automotive design, these use cases actually require such low latency and high fidelity content that it is absolutely a private 5G network is sometimes the only only option in those cases. And the private 5G network that we actually deployed with Supermicro core in there, it's a small suitcase that you can actually carry along with you, and you set up your own private 5G network and have 10, 12 people in the room, executives making design decisions or something like that. Some of those use cases can be easily possible with this kind of a setup.
Good. So Yasser, how do you, from your perspective with the the AI machine learning, how do you see the hardware software demands changing over the life of the network? Do you're going to do more and more processing at the edge? Are you going to drive a demand for more hardware?
Yeah, absolutely. So, from a solutioning perspective, right, like we are working with Supermicro to introduce what is called as factory in a box. It provides an appliance-based architecture which is scalable, which you can deploy within your industrial environment inside your factory, and be able to ingest all kind of real-time data being generated by the production lines. So think about hundreds of robots working in a manufacturing line or different type of complex machine generating data, right? And that has to come into an environment at a low latency, and the traditional network which exists are either too closed or don't allow that type of bandwidth requirements. So being able to layer a quick network along on top of it is very important. And then as you increase the type of data which can flow in, so for example, adding cameras for quality use cases and doing analytics on the video and imaging coming across, creating digital twins of what's going on in the environment, and being able to access it from anywhere. So what COVID and lockdown has shown us is that you don't necessarily can afford to be in the premise to be able to monitor what's going on. So being able to have that information available across from wherever securely, without any disruption. So, and this requirement is going to always keep evolving. So it's very important that both the hardware and the software keep changing, and evolving as well. So.
Okay, good. So Yaming, over to you last on this one, and let's expand this out a little bit. We've had a lot of questions actually came in on both today and also before the call on security and how we deploy security. So obviously that is, security is a hardware solution. It's also a software solution, becomes critical for the enterprise. So as we move through the life cycle of this private network, how are you seeing that security is going to be addressed and integrated with the enterprise solution?
Yeah, I mean, in terms of security, right, there are several different levels of security. There's the on the network side and on the server itself as well, right, and in the cloud. So I'll just address some part of the server itself, right? In terms of we do have the secure boot, a root of trust, to enable that there isn't people who are tampering with the hardware itself and or able to load a firmware or software into our server, right, without have the key recognition. And in terms of the networking encryption there, we typically for the standard, for example, Intel's Xeon D server, the QAT, Quick Assist technology, which will accelerate the encryption and tunneling, is built in. Right? For their more powerful servers, there's additional add-on cards can be added to realize this. And also, it's my understanding the next generation Intel Sapphire Rapids will have Sapphire Rapids Xeon ISP server product and will have this function built into the CPU design as well. So those are all kind of the to be able to address the security. But to back to your original question in terms of the software and hardware update, right? I see there's several scenarios where the hardware or software change. Number one is a spectrum change. It is quite possible the particular country will issue new spectrum for the enterprise to use. In that case, you might need to change the radio, right? That's where the open system will benefit more, because if the all-in-one solutions there, you may have to change everything altogether. In this case, you might only need to change the radio and just update software on your DU, CU, and the core to make it work. The second scenario is, for example, I mentioned the newer CPU, right, from Intel for next gen. Newer CPU or GPUs have been released, and they provide new capabilities that customers really want to take advantage of. In this case, especially the new application software they want to take advantage of, right, will demand the hardware and the software change. Lastly, new software applications created, and the current servers are not powerful enough to be able to support the best use of those application softwares. Then you will need to upgrade the hardware and with the software as well. In this scenario, also the disaggregated design will benefit rather than in all-in-one design architecture. Lastly, I want to just shamelessly share that at Supermicro, we work with HTC, we work with Micro AI, right? We have a very broad product portfolio, probably I would say the broadest in the industry for the telco and in these areas, right? You can choose, because we have this building block kind of a design, can have a Lego design to fit into different form factors to be able to. Also, we release our servers faster with our partner, the semiconductor partners, closely to market. And so have 1U, 2U, or the picture you show right now, like the multi-node design, to provide enough flexibility. As also Venkata mentioned, the all-in-one, the server go into the current luggage design, but also if for a larger design, maybe there will be a different form factor design to fit into customers' use case.
Right. Yeah, it's a very good point. Actually, when I got my server here for my private network, it actually came from one of your partners, and I turned it over. It's like, oh, Supermicro. So you do have, Supermicro does have a lot of partnerships within the industry. Obviously, we've got Micro AI and HTC here today. So good. Okay, we're about out of time. We actually got through a lot of the questions. There's a couple left over, but I will get back to those. We'll answer those separately. I think we talked about most of them already, actually, but there's some very specific kind of deployment questions that have come in. But I want to thank the panelists here today. Obviously, we were recording this. We'll make the recording available. We'll send everybody an email with that, with the details on that. But I want to thank Yaming from Supermicro, Michael from Supermicro, Venkata from HTC, and especially Yasser, because it is the middle of the night for him. I promised him we were going to finish on time or a little bit early because he is in Melbourne today. And Yaming, I know, is in Spain, he's in Madrid, but it's only the middle of the afternoon for him. So
I got a good.
Yeah.
Coffee here, sir.
So Yasser gets the prize. You know, whenever you go to a wedding, there's always a prize for the guests who came the furthest. I think Yasser wins that one today. But I do want to thank Yaming, Yasser, Michael, and Venkata for the time today. Great discussion. We will send it out. We talked about a lot. We talked about virtualized locations using Edge Cloud. We talked about deployment. We talked about the edge. We talked about learning on that, the learning and the analytics on that environment as well. We talked about factory in a box. We talked about AR and VR type applications with low latency. And of course, we talked about Supermicro scaling up here on using the Intel technology, including that underlying technology for things like security. Using the underlying Intel security technology there in development. And Open RAN as well becomes very important in this as we do scale these networks. We're going to see a lot more networks in the next few years. We actually at IGR keep a database of all the vendors and applications and case studies, and we're up to about 90 case studies for private networks around the world. And I expect that to double or triple in the next year. And obviously those applications or those deployments will expand as well. So with that, I want to thank everybody. Certainly, obviously, thank Supermicro and Intel for sponsoring this, and Micro AI from HTC for your support today. For more information on this, you can go to supermicro.com. And as I said, we do have a white paper coming out on this very shortly. Thank you very much.
Thank you.
Thank you.
Thank you.